Welcome to this joint session between NVIDIA and Supermicro about how NVIDIA A100 can accelerate your data center. My name is Charu Chaubal with NVIDIA, and I'll be going through the first part of this presentation. Intelligent applications are growing across every business, from fraud prevention to lower business costs, data analytics to give you faster time to insight, conversational AI to provide better customer engagement, and so forth. You see new products and profit increases across all industries due to these applications becoming more and more prevalent. Let's take a look at some examples. So recently, PayPal was interested in doing real-time fraud detection. They were looking to deploy a new fraud detection system, one that will operate worldwide 24/7 and work in real time to protect against potential fraud in customer transactions. Now, inspecting the system, it became evident to them that CPU-only servers couldn't meet these requirements. Now, using NVIDIA's T4 GPUs, PayPal delivered a new level of service, improving real-time fraud detection by 10%, while lowering the amount of servers needed by nearly 8 times. Another example, the company Friendly, which does medical claims processing, took advantage of AI as well. The situation is that health and life insurance administrators usually spend many hours manually reviewing statements, physician notes, and other forms. Now, digitizing this paperwork has a long history of trial and error, and it's made even more complex by medical terminology and acronyms. Now, by using NVIDIA's V100 for training and inference, the Friendly AI platform was able to transform medical insurance paperwork into a structured, analyzable format, and then use natural language processing to extract information to create digital claims. With this platform, they're able to process claims 40% faster and with 20% fewer errors. So these are just a couple of examples of how AI is transforming many industries. Now, what are the challenges as this AI revolution continues? One of the biggest ones is that the compute demands are growing exponentially. On the left side, you see the size of typical neural networks growing over time. These are the number of essentially parameters and subsequently how the operations that needed to do the training. So what you'll notice is that this is an exponential scale. So between 2013 and today, you actually need 3,000 times more compute required to train these models, to train the largest models. On the right, another point that could be understood, the amount of data is growing also tremendously. So the number of interactions per day that would be processed by AI is in the millions or even billions. So both of these indicate the need for having a really more powerful accelerated platform than we've ever had before. Recently, NVIDIA introduced the A100 GPU based on the new Ampere architecture, and we introduced it in a couple of form factors, NVIDIA A100 SXM and NVIDIA A100 PCIe. And this represents the greatest generational leap in our processing architecture, with 20 times more performance than the previous Volta generation in areas such as FP32 training, Int8 inference, and FP64 for HPC. Let's take a look at some of the highlights. One of the newest features is this new data type called TensorFlow 32, and the new tensor cores that we've created to process this data type. Now, what we've observed is that for doing AI training, you often only need the range of FP32, but a smaller precision, the precision of that of FP16. So by combining the range of FP32 with the precision of FP16, we created TF32. And we've observed that this data type can be used to train networks much more quickly and yet maintain the same amount of accuracy. So you'll see in the chart here that using this new data type, we've gotten a 6 times speed up with A100 using TF32 over the previous generation of B100 using FP32. And the nice thing about this is that happens out of the box. There's no code changes required. How it works is that it automatically converts FP32 into TF32 for this purpose of this calculation, and then converts back to FP32 when it's done. Again, you get the benefit of this 6x speed up without any loss of accuracy. Another really exciting feature is something called multi-instance GPU, or MIG. This is the ability to take one single A100 and split it up into as many as 7 individual GPUs. So you can have up to 7 GPU instances in a single A100. Each instance has its own dedicated SM, its own memory, L2 cache, and its own bandwidth for hardware quality of service and isolation. So what that means is that you can have simultaneous executive workloads with a guaranteed quality of service. All these instances run in parallel with predictable throughput and latency. What this allows you to do is to right-size your GPU allocations. You can take 1 or 2 slices, for example, for one purpose, and then take 3 or 4, combine them for a larger problem. And you can do this dynamically. So it provides for a very flexible and versatile infrastructure. On the chart here, you'll see that as compared with V100, one single MIG instance, meaning 1/7 of an A100, gives you as much performance for BERT large inferencing. Now, if you take all 7 instances and run them independently, you basically get 7 times as much work out of it. So again, a very flexible and versatile feature here. Another great new feature is called structural sparsity. Again, what we've observed and what many people know is that when it comes to certain neural networks, a lot of those are 0 or close to 0. And so what this feature does is that it will automatically skip the processing of those near 0 weights. That is, skip half of the compute and mem fetches. What this results in is 2 times faster execution of calculations on a tensor core. So what this can result in is an overall speed up of inferencing of 1.5 times or more. So again, a feature that will really make it this A100 really suitable for speeding up common tasks, especially such as inferencing. On the HPC side, we have new tensor cores with FP64 format, which is ideally suited for HPC where you need that high precision. And so you can see by using this capability, you get 1.5 times or even up to 2 times speed up versus Volta. And these are available to you through drop-in libraries such as cuBLAS, cuTensor, and cuSolver. Some other highlights we have here. A100 improves SM bandwidth efficiency with a new load global stored shared asynchronous copy instruction that bypasses L1 cache and register file. Additionally, the tensor cores are more efficient because they reduce shared memory loads. The L2 cache residency control helps applications reduce DRAM bandwidth. And data compression also improves DRAM bandwidth, as well as L2 bandwidth and L2 capacity. The third generation of NVLink and NVSwitch make for much more efficient scaling. And as you recall, this technology enables you to combine multiple GPUs into one large GPU. Now, this third generation has up to twice the data rate of V100. And so you have a data rate of 50 gigabits per second per signal pair. So you can have up to 600 gigabytes per second total bandwidth, which is double what you could have with Volta. So the A100 is available in basically two form factors, HGX 100 and A100 PCIe. The PCIe form factor is more meant for mainstream servers. You can have between 1 and 8 GPUs per server with an optional NVLink bridge between 2 GPUs. The HGX A100 4 GPU and 8 GPU are meant for more high-end systems. With the four-way GPUs, they can all be fully connected with shared NVLinks. And with 8 GPUs, you have full NVLink bandwidth between all GPUs with NVSwitch. So again, these are for more scale-up solutions that need more performance. So as you can see here, between the two form factors, for certain applications, the comparison of performance between them two is pretty similar. But for other large applications, such as BERT large pre-training, you can get up to 1.5 times more scaling with the HGX over the PCIe. Taking a step back, A100 represents an ongoing trend of getting much more performance than you could with Moore's law. And so NVIDIA has done this through a combination of hardware and software improvements over time. So for example, going to when V100 was first introduced, it was a combination of hardware and software that allowed it to get up to 2 times performance as compared with the previous generation. But in the 3 years since V100 came out, NVIDIA invested in a lot in software, and using software alone on the same hardware, we were able to increase that to 4 times the performance. And finally, going from V100 to A100 through a combination of new hardware features as well as more software engineering, we were able to get it up to 9 times the performance of the original starting point in 2016. And these are measured using a basket of applications that cover a number of areas from simulation to AI to data analytics. Now, it's also important to understand that NVIDIA provides an entire accelerated computing platform, not just individual piece parts. So you get a complete solution for accelerated computing. So it starts with the GPU. Our GPU provides universal compute acceleration. It speeds up all types of algorithms, as I mentioned. With the GPU, we have CUDA and other software libraries to unlock these capabilities so that you don't have to have a large investment in software engineering to take advantage of the acceleration. We have a very large ecosystem of developers, 2 million developers and counting at this point. So a lot of support behind this architecture. With the recent addition of Mellanox to the NVIDIA family, we've been investing a lot into data acceleration with the Mellanox line of SmartNICs and DPUs, or data processing units. So this lets you have data that's accelerated going from server to storage to network. This hardware acceleration also extends to security so that you can maintain security through things like IPsec and TLS that's hardware accelerated and still have that high bandwidth. This lets you scale up from a single server to a whole data center. The third element here is the ready-to-use software that's available through the NGC hub. So NGC is a software hub where you can download state-of-the-art models, SDKs, and frameworks. These are all made available by NVIDIA for free download by anybody. These models, SDKs, and frameworks are secured, optimized, and packaged for easy deployment as containers. The fourth piece is our NVIDIA certification program. So this program lets customers choose and acquire systems that are ready to use and optimized for accelerated computing. So they have built-in hardware acceleration for both compute and data. These systems are tested and certified for this purpose. And once a customer acquires them, they're eligible for enterprise support and service from NVIDIA for the NVIDIA software running on top, as well as the NVIDIA components running inside the server. And finally, an area not to be overlooked is the fact that our platform is enterprise ready with integrations and features of interest to IT and DevOps. So for example, we have the GPU operator and container runtime, which lets you integrate your AI and accelerated applications with standard DevOps frameworks. We also have integration with popular monitoring tools so that IT admins can monitor what's going on with your accelerators, just like they would any of their other enterprise servers. And now I'll turn it over to my colleague at Supermicro, who will talk about how Supermicro takes the power of NVIDIA A100 and builds a broad portfolio of systems optimized for accelerated computing.
Thank you very much, Charu, to give us such a deep dive on the latest, greatest A100 and what is capable and what can be bring to the new evolution on the AI industry, and how we can put that into our customer hand and how to help out our customer to build application. That's where we are. Supermicro coming into the picture, and that's what we're good at. Supermicro, along partnership with NVIDIA, we always deliver the widest GPU portfolio to our customer in the GPU application-driven market segment. And here's some of the market segment, from HPC to big data-driven application to cloud service or even web host and research lab, etc., etc. So today, I'm so excited here to talk about some of the AMD EPYC CPU-based GPU system we offer on the table to our customer, powered by the NVIDIA A100. Coupling with the latest PCIe Gen 4 technology, they can give us the greatest and most powerful system to our customer. Based on the A100 NVIDIA offer, Supermicro can basically integrate this technology into the most cost-effective solution versus performance depends on what our customer need. So from the bottom A100 PCIe version all the way up to scale the system, we have all the system can offer to our customer. Supermicro always find a way to overcome the thermal and EE mechanical and software challenge, etc., etc., to provide the most highest density and best performance based on the NVIDIA A100 GPU server. So why PCIe Gen 4 matters? It is double the last generation of PCIe 3.0, obviously, but why that matter? If we look at the A100, Charu talked about it. This generation of A100 is more than double than the last generation V100 in terms of power, in terms of bandwidth, and in terms of computation flops, right? So we also need to at least double in terms of bandwidth that the inferior and the I/O connect to the GPU. So that's where the PCIe Gen 4 come into the picture, and we need to use PCIe Gen 4, which double to the last generation, not only between the CPU and the GPU, but also for all the data that need to go to the storage, go to the remote system. That's where the NVMe Gen 4 and also the InfiniBand, also from NVIDIA, come into the place. In Supermicro, we are not only offer the hardware solution, but also the entire solution from hardware plus the software. From first level, we look at it, it's really, we put the greatest latest A100 in PCIe form factor or the XSM form factor into our system. And that enable to do the GPUDirect peer-to-peer connection, as well as SSM4, NVLink and NVSwitch. That enable us to have the greatest and the most powerful bandwidth. Once they come to across the system, we enable the direct RDMA and also the direct storage if we see the system. Beyond that level, we also enable a NICO, which is similar to the MPI. And this is really a technology awareness, the software provided by NVIDIA, and help us to make sure we can optimize based on the CUDA and on top of the greatest NVIDIA A100 architecture to provide as a system to our customer. So our customer can use the Haru, such as open source framework, to program it and provide their application need on their customer need. So today, I'm so excited to introduce some of the greatest GPU system from Supermicro that enabled by the A100 technology. The first one is AS2124GQ NART. And this is really powered by the HGX A100 GPU. And this is really the flexibility and greatest knowledge that we put everything together in this box. And most of the customer, because the thermal challenge, they can't overcome and come into the 3U form factor. But in Supermicro, we optimize the heatsink and come up with unique thermal solution, can put everything into a 2U form factor to help our customer to reduce that rack space and provide higher density. And this system is coming with 32 DIMMs that can be fully populated up to 8 terabyte DDR memory and running at the clock rate 3200 megahertz. And with the 3000 watt power supply, this can be provide truly redundant 1+1. And we have a 5 slot, 4 16 links PCIe 4 slot, and then another by 8. So the 4 16 PCIe slot can provide the 1-to-1 mapping ratio between the GPU and the NIC card. That fully enable the RDMA technology that Charu talked about early in his slide. And that's also provide us the remote connection so that it's scalable if we set up a different server, provide as a solution if the customer looking for a scalable solution. This system is great for the HPC and also for cloud service and also for the government if they're looking for security. Let's look into the architecture a little bit. We choose a 318 gigatransfer HDMI2 interlink between the AMD Ampere socket. And this is all for optimizing all the PCIe link without the PCIe switch. Each of the CPU connects through this HGX A100 GPU without the PCIe switch and direct connect to without any additional latency or delay. By doing so, we also directly connect two of the NIC card to the CPU with the PCIe Gen 4. And this architecture enables us a non-blocking between the GPU to the NIC card. This is supported through the RDMA if the customer needs this system to scale to another solution by connecting to another node or another 2124 GPU NART. And this is a perfect fit for customer driven by performance application, but need the power efficiency with a higher density and scalable solution, such as on the edge, like oil, gas industry, machine learning, academic research, and government application. And this platform is the first AMD-based with NVIDIA A100 that support the hardware root of trust, which is most of the HPC and government application looking for. Here's another XSM form factor system, AS4124Geo NART. And it comes with a 4U form factor and up to 10 NVMe photo support. And it truly is a 2+2 power redundancy with a 3000 watt power supply. And this system is the greatest performance machine in terms of ops and flops, and ideal for the customer really looking for deep learning training or neutral model-driven application, such as research or national lab, and the supercomputer cluster for the cloud service. Let's look at it, the architecture a little bit. On this architecture, we actually use the PCIe switch, and we use the 4 XGMI Gen 2 link between the two AMD ROM processors. And we can support the Milan in the future once it's available in the market as well. Each of the CPU has the two 16 PCIe Gen 4 link connect through the switch and cascade down to the HGX A100 GPU. This helps us to connect all the GPU together without any blocking. The PCIe switch also connects to the NIC card and the NVMe through the PCIe Gen 4. And this allows us to do 1-to-1 ratio between the GPU and the NIC, as well as the direct storage that A100 offers on the table. The GPU is interconnected to the NVSwitch. This allows us to have up to 600 gigabit per second bandwidth between the GPU with non-blocking. And this system is great for, again, deep learning training and model-driven application, that type of customer. We talk about the two platforms based on the XSM4 form factor. How about the PCIe? Today, I'm excited to introduce this 4142GX TNR, which is based on the PCIe A100 with the ROM processor from AMD. And this platform, we can support not only the A100, but all the PCIe GPU that currently from NVIDIA, including the RTX, including the 8000 and the T4 GPU. And this architecture is really flexible enough to provide the customer if they need one PCIe or up to a PCIe GPU. And this will be very great for the customer start to look into less investment from beginning. And eventually they want to have all the A100 powerful for the rendering, for some of the HPC application. And one great thing about this platform is, if you look at the overall architecture, it really depends on what customer need. It depends on cable routing. You can configure into different ways that support up to even 10 PCIe GPU or support 8 PCIe GPU with some of the NVMe in front. Or you can even change the root complexity if you like. And the great thing about this thing is that the customer can do it by themselves in the field, and depends on the customer need. Supermicro Ultra Server always provide uncompromised tool processor and built for the performance for ops with the best class for the networking and storage, and provide the maximum I/O flexibility as well. So with this offer, we have AS2024 TRT, which can also support the A100 GPU that offered by NVIDIA. This is a great fit today for our customer using in the cloud computing, virtualization, and also some sort of web host application as well. And this is enable the customer without buying another GPU system and save the total cost of ownership for our customer by enable this server to support the A100 PCIe GPU. On the cloud end, we also excited to introduce this new server from the data center application. This system really is come with a 2U form factor, which is the most popular form factor in the data center. And it designed for all the customers that in the data center need all the secure-based application with maximum flexibility in terms of storage as well. And it comes with 2 PCIe Gen 4 16-link slots. We certify and we also enable these 2 slots to support PCIe A100 GPU from NVIDIA. This allows our customer to simply put those 2 PCIe A100 GPU into the system as a single box if needed. And this, again, reduces the total cost ownership for our customer and enable our customer to win the business because of cost advantage. Last but not least, we have a 20-node blade server, which built for the highest density and energy efficiency in Supermicro offered today. And this blade system can also support PCIe A100 per node. And this system is built for 20 nodes in an AU form factor. In other words, we can support up to 20 PCIe A100 GPU if the customer needs it. And this is a great application needed for AI machine learning capability if the customer really want to have that kind of redundancy. It's really ideal for customer like financial, stock market, and really need the redundancy and security in mind. And this is the capability of flexibility to support up to 20 PCIe A100. Also gives our customer option in today's AI-driven application market, like financial and stock market. So in Supermicro, we always good known for the widest GPU system, and we have been done for the 5th generation for parallel computing. And mostly, and we partner with NVIDIA. With the long time great partnership with NVIDIA, we enable today, again, with all this A100 based GPU system in the PCIe form factor as well as SSM form factor, we always building the GPU system, the faster, the better, and greener. So if you are interested on Supermicro's server and service, please make sure you visit our website and look at our 2 other sections from our colleague. Thank you for watching.
Introducing the AS-2124GQ-NART server featuring the NVIDIA A100 Tensor Core GPU. This system uses the NVIDIA HGX A100 4GPU baseboard and features custom-designed heatsinks to enable 400-watt GPUs in a 2U form factor, with system fans providing sufficient air cooling even when the CPUs and GPUs are operating at maximum performance. With faster new PCIe 4.0 performance, the system features plenty of expansion slots for high-speed networking support, including 200 gigabit per second Mellanox HDR InfiniBand SmartNICs. GPUDirect RDMA and one-to-one mapping between the network cards and each GPU ensure maximum system performance. For flexible storage support, 4 hybrid hot swap 2.5-inch drive bays support SAS, SATA, or NVMe drives, And with NVMe drives, the system can support GPUDirect Storage. Leveraging the latest generation of NVIDIA NVLink technology, the system provides GPU-to-GPU communication speeds of up to 200 GB per second. The NVLink connections are arranged in a full mesh configuration, so all GPUs are talking directly to each other, which helps to reduce the performance bottlenecks. The system features a true 1+1 power redundancy with an option to upgrade to 3 kW power supplies. To power the GPUs, the system supports dual AMD EPYC x86 processors. Each AMD EPYC CPU supports 80 lanes of PCIe Gen 4, up to 64 cores, 8 channels of memory, and up to 280 watts TDP. With 32 DIMM slots, the system supports up to 8 TB of DDR4 3200 MHz memory. Our GPU systems are purpose-built enterprise servers optimized for GPU rack density, GPU connectivity, and the challenging power and thermal demands of these systems. This product is particularly suited to HPC and AI workloads. It will help drive breakthroughs in areas like speech recognition, computer vision, and data science. These target markets require massively parallel computations, and our 2U4 GPU solution is perfect since it is optimized for the high bandwidth connections between the GPUs. For more information, please visit us at supermicro.com.